Welcome to today's class. Today I'll be giving you a basic introduction to trigonometric graphs. We will be going over the shape of sine x and cosine x and the relative jargon associated with their shape. I know, you're probably thinking, what? Well, let's dive right in. These are our terms: amplitude, period, phase shift, and vertical shift. The amplitude, or height/depth of the graph, is the distance from the x-axis to the top or bottom of the wave. The period, or wavelength, represents how long each wave is. The phase shift represents how far the graph has moved left or right from its original spot. The vertical shift is how far the graph has moved up or down from its original spot. We will learn how to find these later. This is the standard sine graph. As you can see, it has a wave-like shape that goes through the origin. It has an amplitude of 1, no phase or vertical shift, a period of 2 pi, and a frequency of 1. We will learn how to find all of these later. This is the standard cosine graph. It, as well, has a wave-like shape, but does not pass through the origin. It has an amplitude of 1, no phase or vertical shift, a period of 2 pi, and a frequency of 1. Now that we know our basic graphs, we can learn how to find amplitude and period. The formula to the right demonstrates what the formula looks like and what will be used. Now let's look at the graph on the left. The orange wave is sine of x and the blue is 2 sine 3x. How do we find the amplitude? It says above in the highlighted formula that amplitude is the absolute value of a. And if we look at our formula above, we see that a is the value before sine. Now if we look back at our graph, we see that the number before sine is 2. And the absolute value of 2 is 2. Therefore, 2 is our amplitude. Let's look at the graph at the right. Orange is cosine of x, and blue is 3 cosine 2x. Now let's find the period. In the highlighted formula, it says that the period is equal to 2 pi over b. So if we look at our formula above, we see that b is the value right before x. Therefore, our period, if we look back at our formula, would be 2 pi over 2, which would reduce to pi. So our period, or wavelength, would be pi. Now that we've covered amplitude and period, let's learn how to find phase shifts. Let's take a look at the graph on the left. The orange wave is 2 sine 3x, and the blue is 2 sine 3x plus 4. If we look at the highlighted formula, we see that the phase shift is negative c over b. So if we look at our formula to the left, we see that c is the value that follows x, and b, like we learned earlier, is the value before x. So if we look back at our graph, we see that our phase shift will be negative 4 over 3. Now let's look at the right graph. What would be the phase shift for this graph? Do you see it? The answer would be negative 5 over 2. Finally, we have vertical shifts. Let's look at the graph on the left. The orange wave is 2 sine 3x, and the blue is 2 sine 3x plus 4. Only this time, the 4 is outside the parentheses. Therefore, its role is different. Instead of determining the phase shift, it determines whether the graph moves up or down from its original spot. A positive number means the graph goes up. A negative means the graph goes down. So if we look at our formula above, we see that the vertical shift is the number after the parentheses. So if we look back at our graph, we see that 4 is the number following the parentheses. Therefore, plus 4 is the vertical shift. Now let's look at the right. The orange wave is 3 cosine 2x, and the blue is 3 cosine 2x plus 5, with the 5 outside the parentheses. Can you tell me what the vertical shift is? I know, it's pretty obvious, but still. Yes, the vertical shift would be plus 5. Now that I've taught you everything you need to know, it's your turn. It's your job to identify the amplitude, period, phase shift, and vertical shift that corresponds to the formula below, and sketch the graph. Stop the video here and answer the problem. Here's what your graph should have looked like, and here's what you should have got. An amplitude of 3, a period of pi over 2, a phase shift of pi over 8, and a vertical shift of plus 1. We know the amplitude is 3 because it's the value before cosine. However, it's 4 units above the x-axis. From that, we can infer that the vertical shift is plus 1. We know that it has a period of pi over 2 because the formula for finding the period says it's 2 pi over b. And if we look at our formula, we see that b is 4. Then we have 2 pi over 4, which reduces to pi over 2. Lastly, we know it has a phase shift of pi over 8 because our formula for phase shift says it's negative c over b. Now, if we look back at our formula, we see that c is negative pi over 2 and b is 4. So divide positive pi over 2, because a negative times a negative is a positive, by 4, then keep it, change it, flip it, and you should get pi over 8. Alright, that about wraps up today's lesson. Thank you for watching, and hope to see you next time.